Hi, I'm Shan Smith with Good Sense Automation. Good Sense Automation is a systems integrator, and we're located in Greenville, South Carolina. Our sweet spots are vision, robotics, PLCs, amongst other things. So this is a short tutorial on the off delay timer. An off delay timer works much like the headlights in your car or the dome light in your car. You turn off the car, switch, or start button, in this case a stop button. You have removed your input, you have removed your signal, and then 5, 4, 3, 2, 1, your lights go out. You remove the input, and there's a delay in the system or the output or the controlled element being turned off. I'm going to do this demonstration with an Allen Bradley controller. So stand by and let's get into it. All right, let's talk about the off delay timer. So the off delay timer is just that. There's an off delay before our output changes state, or before the contacts change to their normal state. So I'm going to go online. And I've just made changes to this program. I know exactly what's going on with the controller. So I'm very comfortable with my download. Always make sure you're comfortable with the download, which means you understand where your control logic is and where your control logic is going if you're in the field application. You have a lot of warnings. You're downloading, the controller is in remote run mode, it will change to program mode to download, which means your controller is going to stop. Do we want to change the controller back to run mode? In this case, the answer is yes. Make sure you know the state of the system that you're working with. All right, can I find my logic? So I have an off delay timer. Keep in mind, you have to give the timer a tag name. You have to assign a preset count. In this case, my preset count is 5,000, which means that it will be a 5-second period before my contacts change state. So this is my timer done bit. It's the same tag name, light timer dot DN, light timer dot done. So I'm going to toggle my test bit. Now you notice that the instant that I toggled my test bit, the instant that the input went high, my done bit went high. And this is because the delay is in the off process, not the on process. It's an off delay timer. So now, when I go back to my test bit, toggle bit, my timer done bit is still on. My timer is counting, and it counts until we go through the 5-second interval, and then the off delay bit turns off. It's an off delay timer. What else can we do with this? What else can we examine with this? Let's add a doing an online change. So when I double click to the left of my rung, I can do an online edit. The I is the rung that I'm changing. The R is the rung that's currently active. I'm going to add a parallel branch. I'm going to add a second parallel branch. And I'm going to add another set of open contacts. And I'm going to copy the instruction and paste. And I'm going to add light timer dot TT, timer timing. That means that this element is on anytime the timer is in the count process. I'm going to add a light timer dot en. And the difference between the three, light timer done, your preset count counts down, and the off delay timer then changes back to its normal state. If it's normally open, we go back to a normally open state. If it's normally closed, we go back to a normally closed state. The timer timing means that we have a set of contacts that are changing state during the count process, during the timing process. And then we have the enable bit, which means we have a signal going to the timer off delay. And during that time, these contacts change state. Let's take a look at it. I'm going to accept my pending run edits. And then I will finalize my pending run edits. Finalize all edits in program. So not if I have edits anywhere else in my program, they're going to be finalized now. And yes, we have put this in. So again, the done bit goes high immediately. The timer timing bit will not. The enable bit will go high immediately because I'm putting a signal on the timer. And the timer timing bit will go high during that 5-second count process. Let's take a look at it. Toggling my test bit. And we notice that we have the done bit is high because again, it's an off delay timer. The enable bit is high because we have an input to the timer, and the timer timing bit, we have a logic 0 or a low or a de-energized state due to the fact that we're not timing. So let's toggle the test bit again. Toggle bit, timer timing, done bit is high, and then we time out. So that is the off delay timer. If you have any questions about the off delay timer, please reach out to me, Shan Smith, Good Sense Automation. Have a great day.